In this video, we're going to take a look at protecting the data or variables of a class. So we're going to start with kind of an example of why we want to do this. So there's lots of reasons, and there's more complicated reasons, but this is kind of a simple example just to get an idea of why we might want to protect the class in terms of what it's made out of, its properties. So here we have an example where we have a class, and we have it minimized right now, so we can't see what's in it. And we have this idea where we're making an instance, and then we're applying some functions to it. I'll say that the character class is maybe, you can think of it like a class for a game of like a hero and or enemy objects. So you can imagine maybe it has a whole bunch of functions. We don't know what they are. We can see here that this program is set up to use a lose health and an add health function, and they do something. And we could really work through what this does in terms of starting with a health value. We don't know what these are because we don't really see what this is. But if we're imagining that this is like not our own object, not our own class that we made, we're going to pretend it's like an import, like a module. Now, we could make this a module and put it in a different file here and import it. But just for the sake of editing it really quickly, we're just going to pretend that that's what it represents. So something where we can't necessarily easily see what the class is made of, what its properties are, what its functions are, and we're kind of imagining where we're using documentation to be able to tell how to utilize or use these objects or instances of this object class. So if we take a look at this, we'll just say like this is the starting health, and we're adding 20. So you can see we add 20 to the health, and then we take 20 away, so it goes from 80 to 60. We add 10, it's now 70. Let's rerun it to clear out this thing. And so we added 50 back in. I don't really know why it's 50 because I started at 80. I took away 20. That takes me to 60. Adding 10 more is 70. And adding 50 would be 120, but we say 100. So I don't really know about that. But because it's our own class, and even if it was a module, we might be able to dig around. If I said something like Paul.health, we might be able to determine what that is. Maybe I know that that's the property of it. And I might say something like this. I'm going to add 10 to it. And I can just do something like this to run my function. Okay, Ripple's having a hard time here. Oh, right. And then I'll do this. Forgot to put that print line in. So I'll run it. It's 110. So the plus 10 worked there. So, okay. Now, so these are very different, right? Here I've used functions to change the value of the health of this object. Again, I don't really know how these are stored. I'm guessing when I do this and think, oh, I found out that there's a health property that I can just add a number to. I mean, they print like integers, so it seems like they're integers. I think they're stored as integers. But now I've kind of done this where I directly affect the property. Now, this is a little bit different. Now, the kind of metaphor that I'm going to suggest we're looking at here is the idea that if we have this character object, so let's just think of it as like, I'll just draw it simple like a box. So this is a character object. Here's Paul, right? Paul has properties inside, and we can ask it for it. So we can ask about this health and whatever else. So add health is kind of like, it has a button on the outside or something, and I press it and I say, hey, I want to add the health, or I put the number in here, I type it in, I press enter, and it goes and it does its thing and adjusts the health, right? And it kind of does it in the right way. Like it's a machine and it's got an interface designed for me to, type in, I want to add 20, it goes and does its thing magically, I don't know, and then the health, I've now subtracted 20 or added 10 or whatever I'm doing. This version here is different. This version is like I bust open this box and I take off the lid and I reach inside and I mangle kind of what's inside, and just with a little regard for how the machine works. And I'm just going to change that value. Now, that maybe sounds horrific, right? Like I've destroyed it and done something bad. In practice, it might be okay, right? On certain projects, that's not a big deal. Like, right, I just went in, it's fast, seems easy. What's the big deal, right? In the case of this, though, is we might not know how, since we don't know how this is stored, if we start using this version here, we really start to think of it as that this is always an integer. So if this health variable or parameter or property, sorry, is an integer, we're always going to treat it like an integer. What if it's not an integer? What if it changes one time? What if it starts being held in a different way? Every piece of code that is calling or using this module or using this class is now going to change if this no longer is an integer. And it might make sense, and it might not be a problem because the code that was using it referred isn't a big deal. And if it changes to a float or something, that no other code really breaks. But it might be something that makes it break. And that's because we've created this idea of some sort of object dependency. Like we are depending on the fact that this doesn't change. And if it did, ours might not work. For example, health might not be an integer anymore. Maybe it's stored as in a different way. Maybe it's an element of a list, or maybe it's part of a tuple, or something like that, right? We can't be sure if it changes. But if it does, all these things that depend on it would break. So we want to create something that restricts access to the reach inside and get to the guts of our object kind of way, and make sure that we only really always go through a function. And so we want to restrict access, and this helps maintain the integrity of our object. So here's what that looks like. So here's our class. We're going to hide these two functions here for now. So there's a couple things going on. So one is we save the name, so it actually saves this string that's getting, in this case, Paul. It takes a type integer in, and that just determines what type of character we're making. A hero and a zombie are our only choices right now. And I've kept it simple. We're not checking a million things, and we just want a small enough example that we don't have to think too hard about the data hiding bit. And so it chooses, if you put in 0 and you're the hero, it changes your type to a hero. So there's a self.type, and they also have a property called max health. So it's 100 for a hero, it's 50 for a zombie. And then I also do this to make sure that the health doesn't exceed the max health. So even though this health value is coming in, so for example, we were creating Paul with a health of 80, we also want to only make sure it doesn't exceed the max health. So there's no going over max health. So in this case, I take the minimum of what was entered versus what the max is. So for example, if health comes in at 5,000, the minimum between 5,000 and max health, in this case 100, the minimum is the 100, so we go with this, not the 5,000. But if health is something like 80, the minimum is the 80, not the max. So we still use the one that was coming in as long as it's valid. And we should probably check something else. Maybe we didn't want to have negative health or something like that. And this is why before in our example, when we added the 50 back in, we still only went up to 100. And one thing we noticed that, well, if I do this, I've actually allowed this system to over health the object, right? So this, someone might be able to start using this and not realize that they're pushing the health value over something that was never supposed to happen. And now that might be a problem for later on using this module for something. So it's kind of another issue where protecting it and not allowing that to happen is going to be important, right? So how do we do that? And you can see we don't even have to look at these, but they're kind of the same thing. They're exactly what you might think of, where we're taking the amount and we make sure it doesn't go below 0. And I have a different version just so you can kind of see they do more or less the same thing in different ways. This one uses a conditional statement. This one uses the idea of a minimum value to make sure we don't go, this is the same thing as this basically, to make sure we don't go over when we add it. Okay, so we don't really have to focus on those. We have to focus on here. How do we protect that? To make it truly protected, we're going to use some underscores of our variable names. Now, Python does this thing where if you put a 1 underscore under, what happens is that's kind of like for programmers. Python thinks that is for programmers to say, hey, don't use this directly, right? Like you can still access it, but you probably shouldn't. We're going to do something to fix it. And use 2 underscores, Python does what's called name mangling. So it does a better job of hiding what the actual variable name is. And name mangling is more important when we start talking about inheritance, but that's a different discussion. So for now, just for our sake, we're going to use a single underscore for all of our variables. So basically, everything is going to be that we refer to here in our init as an underscore. So we'll start here, and we'll see what happens. Right, so we're gonna do this. So we have these underscores all to start. Now, if I run it, oops, we can see that we get an error right away. Object has no attribute health. Right, so you can see that obviously error is coming out on line 21. So if you look down here, oh, this didn't work, right? It looked for self.health, but it can't find it because it only has a self.underscore health. So it's actually a different variable name, right? And we could fix that one by an underscore. So certainly we could do something like this, and we're just if we just do this, we're just underscoring everything, and changing. It's not much different than just changing the name of a variable in some other way. So we'll do something like that, and then you click run. Let's give another shot there. Make sure I got them all in. Not really refreshing here. There we go. So now you see it's just happening on the Paul line when we go to print it. So this is different. So you can see right now we have this error on line 34. So again, maybe we say print Paul underscore health. And I put an underscore in there. And you can see it still does it. So you can see that the error now moves to 37 because this one works. So that allowed access. And that's not what we're after. So this one is still like able to go in and access it. And if we did that, it would also work for here, where we could just say underscore. And that isn't going to achieve the goal we want. So it's not about doing that here. We're going to do a different approach. And that way we also don't have to put underscores everywhere we refer to health, because for a couple of reasons. One, it's kind of annoying to see these underscores everywhere. So we're going to do something else. We'll leave these ones in the init function. We're going to make basically a special, property object that exists inside the class. So we're going to use this, we're going to make a property object by doing this. And so we're basically going to define it like a function. So I'm going to define a function with the thing I'm talking about. So we're going to use health. That's the property. So I'm going to say self, and I'm basically, all it has to do is it just has to return self._health. So that's all it is. And this thing is called a getter. Now what its job is to do is to go and get the self.health and return it out. So it's the interface. It's right now acting kind of like this wall. I mean, it's not one of these functions yet, but it's kind of like a thing that blocks it from accessing it directly. So let's see what happens if I run this. We're at line 25. Let's fix that up. Okay. So you can see here, we have this issue where we're still getting like this error that says can't set attribute. So we don't have an error because it can't get it. We have an issue because we can't set it. So this is trying to actually change it. And just to verify that, we'll kind of just take these out for a second. So we'll take out the actual functions. It's obviously going to cause an error down here when you try to lose the health, but there's no other issue. And in fact, if we just make this a little bit easier and say, just to verify it, we can say print paul.health. So I'm just going to print it to make sure that I can still get the value out. So you can see now when I run it, I do get it. It doesn't give me any other errors because I deleted all the other stuff. So it's just going through here. So what this does is you don't have to put bracket. So it looks like a function where you'd think, oh, I have to put two brackets. But this is a special property object, so you don't. You just have to treat it like a parameter, but it's going through here. Okay, in order to test what this might do is we might actually, just in a small test, we can actually say, instead of returning just the health directly, I'm going to make it a float. That's what I'm going to return. I'm going to return a float version of my health property. And now when I run it, you can see, even though I'm calling health, what looks like the property, this thing is actually the thing that's making it work. So that's the idea behind using a getter, where when we ask for it to go get the value, it goes through this thing to go and get it. And we can make those changes. So for example, a character might have held a whole bunch of things as might have held a whole bunch of things in a list, and this is only referring to one thing out of that list. It might be doing what we did now, where we're converting it. Maybe, for example, maybe we're going to change it, and we'll show what that looks like. We're going to change health to be made of floats, but we're always going to return integers. So maybe there's something called like, half health or something that divides it by 2 later. And we're going to actually store these values as floats, but always output them maybe as integers, because we're just going to give nice, easily rounded answers or something. But to keep a more precise calculation of health, maybe we actually store it as a float, right? And it's just the integer rounding we do at the end. So that's the getter. So we already saw the problem, though, is I can't change it. So when I, again, run this now, and I go to do something like lose health, so I say Paul dot lose health and take 10 away. When I run this, we get this error that says can't set attribute. So I can't set the attribute here, right, health, because this thing is only the getter. I don't have the setter for it. So we have to create that. Now the syntax here is a little bit odd. So remember, it was kind of weird to see already that, we said define health, which is the same name as this attribute. And that's kind of weird, and then we used it without the brackets. It gets even weirder with setters, to be honest. So instead of saying add property, we're going to do it a little bit different, where we're going to call it, we're going to say the same thing. So we're going to say name dot setter. So we're going to say, this is the thing we're creating. I'm creating a setter for name. Sorry, not name, health. So we're going to say this health variable, right? You can see they gave me the error, because you have to have this property defined first before you call it, give it a setter function, right? So this thing is building the health property object, and then this thing is giving it, essentially a function. If you don't do that like I did, and you say, well, it's name, it doesn't work until you first set up name with that at property. So this thing is going to have the same kind of signature for the function. It's also going to be health. The difference is, in addition to this self variable that you give it, it's also going to have, the value, let's say, that you want to set health to be, right? So now in this case, again, we're setting it, so this is the new value. So again, we do the same thing, similar thing we did before, but this time we're saying like self dot underscore health. So we're kind of referring to the actual attribute in this underscore version, and we're going to say it equals value. And now when we run this, it now has a setter that it can basically do this to. So when we say self.health minus subtract and sets it to take away the amount, it doesn't do it directly. It goes through this setter function. And again, we could use this to do certain things. For example, let's say I always wanted to be amounts, and everyone on the outside thinks this is an integer. What if we actually want it internally to be a float? What that means is we would say something like, for example, if these are all set up to look like floats, you might say that equals the float version here. So I'm going to maybe say we're always going to keep track of the health internally as a float, as a decimal. We're going to be super precise down the road. So when I return it, I always want to return the integer version. And likewise, when somebody, for example, this doesn't really matter in this example, but if someone's setting the value, I want to always save it as the float version of that value. So to the outside world, we always print it as integers, but actually it's all being stored internally as floats. But you can see when I print it, it looks like an integer now. And when I was setting it, I took that integer in and I converted it to a float. And that could be even more complicated, right? The setter could be putting it into making a tuple, or it could be putting it as an element in a list without us actually knowing. And so these are our getters and our setters. We haven't talked about, there's also a deleter, which we won't talk about in this video, but that's another common one in order to delete something, right? So, that way if I had a list of character objects, it would be easy to use Python syntax to delete one of those character objects to free up our, help us free up memory or just remove it from the list. Okay, so those are the two things. And now, again, down here, these things are the same thing. When I say this, it's again, that's using the setter, right? And same thing when I print it here, it's using the getter to be able to print. But that means we are protecting, in this case, a little bit about how those things really are. So even if now I think, oh, I know the property, I can use health, we've kind of protected it from things. Another option for, as an example of using the getter or the setters, might be just making sure that this is even a float. So you might have something like if you might ask, is instance a value of float, or so this is checking what the object type is. So you might ask value, are you an integer or float? Oops. Are you an integer or a float? And if that's true, then we're going to do this. And that's the idea is here, right? We're checking like to make sure that this person or whoever is using this other class or whatever, that they can't try to set the health of something to, I don't know, accidentally a string or something. So we're protecting it to make sure it's this. And again, we already set it, but we forgot to do, we forgot to do this. We forgot to make sure it doesn't exceed the max. So maybe I need to add this in there as well, right? So I need to say, oh, I can't just take any value and just because it's a float or an integer, just save it. I also need to make sure I save it as, the float version of, the minimum between my current health, right? So, sorry, the minimum between the health, sorry, not health, but value, right? So we're going to say the minimum version of value, or, I'm having a hard time typing, minimum version of value, or the minimum of self.max health. So whichever one's smaller, right? So basically, if you give something greater than the max health, it'll use the max instead. So we're also protecting it from going too large. Just double check, nothing seemed to change. We're not doing any kind of robust tests here, but didn't seem like an error. And then we can check some of those things, right? What does it look like if I say, for example, add health, did my protection here work in terms of my if statement? And if I try to add health and I add 100, or I attempt to add 100, what happens? Oh, sorry, we get this little error here based on my underscore. So again, remember, max health was this thing that I needed to underscore thing because I haven't made getters and setters for it. So I still have to internally refer it as an underscore thing because it doesn't have a getter or a setter. Okay, so it's 100. So you can see it didn't go over. Again, we'll make it 1,000, right? Oops. So we'll see what happens. Oh, what happens if we try to add way too much? Definitely, for sure. Nope, still 100. Still didn't cross the max because of our check here. Again, it should be clear that we're definitely going through the setter, not directly attacking or adjusting health kind of internally somehow. And again, I maybe test something else. So I tried to 1,000. That didn't work. Let's try doing something like, instead of adding health, we'll say Paul.health equals lots of health. And we'll start trying to print that as well to see what that does. I'm having a hard time printing. There we go. So again, it's still just printing the 100. That doesn't work in anything. This is probably something that, again, should it involve error checking and raise an error? Yeah, maybe, right? So where it should raise an error that says it can't be, must be an integer incoming or a float and can't be a string. Sure, but this isn't the topic in terms of throwing exceptions here. So hopefully that explains a little bit about why we want to hide our data and then what we can use it for. It's good practice. to get into. Again, it's not critical in lots of cases, but it has lots of upsides. It's kind of a drag for some in the beginning. Sometimes people get a little bit, depending on how many variables here, to have properties for all of them. So sometimes you might see like larger programs that have lots of variables have a whole bunch of getters and setters. Um, this is a little bit different in Java, for example. And some people even write scripts to write all their getters and setters for them right off the top and just automate that process. Like you can literally write a program in Python, let's say, to write your own Python chunk based on names of or the names of your attributes. So again, this only works with the health. Anywhere that I was using max health or type, I would have to still refer to it as an underscore, or I'd have to start making getters and setters for it, which I should do. If I don't, it kind of defeats a little bit of the whole purpose. But again, sometimes they're simple, just like this, where they're just getters. They don't have to change much. Maybe they don't have to change at all. I don't even need the integer. So they're little simple things to add that can add a lot of robustness and, like I said, integrity and protect that object from being kind of misused or creating a dependency that's a problem. So the problem dependency is I want to change what my object is in here, and it breaks everybody's code because they were relying on it to look a certain way. And if I want to change the internal representation, I break everything else that relied on it. So that's why we want to not allow people to create those dependencies in that way.